Yeah, Robert.
So then is that to say, because the bulk modulus in general is defined as 1 over the compressibility. So
yeah.
would that mean that the M star modulus here is something like a bulk modulus for porous materials?
It's not, that's the undrained bulk modulus, the one we calculated like 15 minutes ago. But it's...
Why do we use M star there? If we're talking about it being related with compressibility, why do we use an M star there rather than the undrained modulus?
Because that's how we end up here with the equations. That's the actual link between variation of pressure with time with variation of pressure with space.
Okay, so it's just what I missed.
Yeah. The other one, Ku, is variation of pressure with variation of volumetric strain. So that one is also there, but it's together with this one because we have another term to quantify that. So if you look, the alpha m is also over there.
Okay, I do have a question about this.
Yeah. Okay. Let me tell me, please.
While is the equation sheet we're going to have on our exam exactly the same as the one on the old exam?
Yeah, I would say so.
That would help to know which equations to look at in depth.
Okay. So in case you haven't gone through the exam, it's right here. So, I told you that you should look at if you haven't done the exam yet, I'll recommend that you take a look at it before and then you try to solve it, okay? But don't look at the solution right away. So oh, Brazil is winning 1-0. Not too bad. Yeah, though. All right. So you bring a calculator. You might need a calculator, but some of those are very simple numbers, right? And equations that most of the time I hope they make sense, like a deviatoric stress tensor. I guess you don't have to memorize that. You just have to know the concept. We have talked about scalars, vectors, and tensors, right? So that's something that by now should be more or less clear. Easy concepts, easy equations like volumetric strain, like bulk modulus, like constraint modulus, Young modulus, Poisson ratio. Those are things also that you should know. What else? Please stop me if there is something that you want to ask about some of these equations. Okay, this would be an example of an equation that it has a lot of meaning into it. So each term is horizontal stress that comes from a different source. For example, this one comes from vertical stress, the Poisson effect of vertical stress. This one comes from also a Poisson effect, but from horizontal stresses. This one in one direction, and this one in the other direction. And it makes sense, look, that if you link H max with H max, there is no Poisson ratio. If you link H max with H min, there is a Poisson ratio. So actually, these two are Poisson ratio effects. This one is a direct stress because of the strain in that direction. There might be, for some questions, there might not be like just an exact solution, okay? If you more or less address the question and you tell me what you understand from there, you can find like different solutions or alternative solutions for the same problem. So particularly for this question, I'm not asking you to replicate exactly what I said, but it's sort of like those drawings that kind of explain that what kind of energy you can put into a solid. And the equations, well, ideally you should write the equations too, but again, they don't have to be exactly the same as the one that we saw in the lecture. So what do you see here, guys? Yeah. Yeah, but in simpler terms, so there, what you say is correct, but you're reading the equation, right? But I like that you told me physically what it means. I'll try to be very specific with the language I use.
Are you looking for DSM, volumetric strain equals K, and DSM, is equal to -ρ?
Well, no, it's more total stress. This should be effective stress. This is just pore pressure with the PO coefficient. So it's simply this an effective stress rule. John, you were raising your hand?
Could you also say that it's the change in total free energy of the solid with respect to volumetric strain?
No, because you have changes of you could have here changes of pore pressure, changes in volumetric strain. You could have both. It's just an effective stress rule. And okay, so this is what we just saw, right? Undrained bulk modulus. So here I'm not asking you to derive all of what we did in class. It's just to define, right? So what is Ku? How do you define Ku? It's the variation. It's a bulk modulus, but with undrained loading. That's it. Yeah, but so if I were to write the equation for that, I would say Ku is the variation of mean stress, and even you have the equation with variation of mean stress, and here you could say undrained, or you could be a little bit more specific and say no variation of amount of mass in the pore space. But if you have just that's enough. I like these problems, guys. I like these problems with 1D strain condition and working through the elasticity, the stiffness tensor, in order to figure out stresses as a function of strain. Actually, we didn't get to that today, but I think in the last exam also we got to see thermoelasticity. So you can do similar things also with thermoelasticity. So you know which one I mean here? This was the drain problem that we solved last week. So let me go quickly through that. Is this one. This one over here. So you work through the equations, make this 0, and then just do a little bit of mathematical manipulations, and then you get to that result. Any other questions? No? We'll try to be on time, okay? So you have more time to solve the exam. Again, it's going to be 1 hour, 15 minutes, right? But you'll see it's not going to take a long time. If you know everything, you should be able to solve it in 40 minutes or less. All right? Okay, guys. I'll see you on Thursday then. Okay. Yes.
Could we meet in like 40 minutes in office?
I'm going to be there, yes.
Okay, thank you.
Yes, I'm going to be there.
Hey, Professor.
Yes.
I wanted to apologize for coming in late today. The lab I'm TAing ran long.
Yeah, that's okay. That's okay, don't worry. Yeah.
And then the other thing, as far as the homework goes,
Yes.
so
Let me stop the
just
camera.
in case you haven't seen it, I turned it in late.
No, I think I saw it.
Just in case you didn't see it,
Yeah.
I'm not like looking